Good morning, ladies and gentlemen. Today we are going to start chapter 11, which is all about polymers. And specifically today, we're going to look at addition polymers and the process by which they are made, which is called addition polymerization. Okay, so the first thing that you need to know is that you come across polymers in your everyday life every single day, multiple times. I would be highly surprised if you could go through 10, 20 minutes without coming into contact with a polymer. Because basically, polymers are plastics, or plastics are polymers, to be more correct. Okay? So in the picture that you can see on the screen, there are numerous examples of polymers, all the way from the plastic bag to the material used to make the raincoat, to the plastic used in the games console, to the filling of the nappies. Actually, a lot of window glass is now made from polymers. We can see loads of different uses all over the place. Possibly even the sofa is made out of a polymer. It might be made out of real leather from the skin of cows, but it's not particularly likely. It's more likely that it's made of polymers. Okay, so it's used absolutely everywhere, different polymers. So what exactly are polymers? Polymers are very large molecules which are made when many monomers join together to form long chains. So the picture you can see on the screen at the moment with the very long chain of circles all joined together, that entire thing could represent a polymer. Okay? It's a long molecule made up of many parts or many monomers, okay? Which means that the monomer is represented in this diagram by a single circle. Okay, so that's the monomer, and the whole long chain is a polymer. Now here, it's been represented as lots of circles joined together. In reality, those circles would be individual molecules, and we're going to look at what kind of molecules they could be in a minute. Okay? You'll never get tested on this, but it's interesting to look at because it'll help you to understand the word better. Okay? So the word polymer comes from two Greek words. It comes from poly, which means many, and meros, which means parts. So literally, polymers or polymeros means many parts. So it really describes what the polymer is. It's a large molecule made up of many parts. Okay? Likewise, monomers also comes from the same sort of idea. Mers still meaning parts, and mono meaning one. So a monomer is one part, and a polymer is many parts. Okay, and these plastics, the polymers are used, remember, to make plastics. We can shape them using heat or pressure, but their properties are really going to depend on what the monomers are, which molecules are making up our polymer. So if you look back at this picture here, okay, you can see all of these different uses of polymers. Now, some of them are really light and really flexible, like the plastic bag, whereas some of them are really tough, like the glass window. Okay, so why does that happen? Why do these plastics have all of these different properties? They have all the different properties because they are made up of different types of monomers. Okay. So what actually holds this big, long molecule together? Well, the monomers in a polymer are held together by covalent bonds. So this goes back to our unit on bonding. Okay, it's a covalent molecule, a giant covalent molecule, in fact. And we know that in a covalent bond, every atom is sharing one or more electron with another atom. Okay, so whereas before I was representing my chain using the circles, actually that chain is going to be made up of loads of atoms joined together. So here I've got a big long chain of carbon atoms which have hydrogens attached to them. This is my polymer. Okay, and my polymer is all held together by covalent bonds, and those covalent bonds are represented normally using kind of that stick format that we've seen before when we were doing Unit 9 and Unit 10. Okay, so some definitions that you need to know. Okay, we've already talked about polymers. Okay, a polymer is a substance made up of very large molecules, and those large molecules are made of many repeating units. Those repeating units are called monomers. Monomers are small reactive molecules that can react together in repeating sequences to form a very large molecule or a polymer. Okay, there's more than one type of polymer. For today, we're going to focus on addition polymers. And addition polymers are formed when alkene molecules react together in repeating sequences to form a very large molecule. That process where they add together is called addition polymerization, and it normally needs a catalyst. Okay, so as we've said, a lot of polymers, all addition polymers, are made from alkenes, which remember are a family of hydrocarbon molecules which have the general formula CnH2n. And they've got at least one double bond between their carbon atoms, which makes them very reactive. Now, we've already seen examples of these. Okay, so the simplest one is ethene. The second simplest one is propene. They've both got one double covalent bond in them. Okay, so polyethene, which is sometimes called polythene, is the polymer that's been made from ethene. Okay? So polythene is the material that plastic bags are made out of, for example. So in order to get polyethene or polythene, you have to add together many ethene molecules. Okay? So this is made using the process of addition polymerization. And what's happening is you are taking many ethene molecules. So these are all individual ethene molecules, and you are adding them together to make the polymer. So at the top, you can see the monomers. The monomers are undergoing addition polymerization, and when they do that, they become polymers. Okay, so what's actually happening in this process then? We look at our monomers. Okay. Our monomers all contain a double bond. And what happens is one of those bonds breaks. So the double bond breaks and leaves behind just a single bond. Okay. We know that carbon needs to have 4 bonds in order for it to be stable. Now that the double bond has broken, it doesn't have 4 bonds anymore. It's only got 3 bonds, okay, which isn't stable. So what happens is this carbon joins on to the next one, and then this carbon to the next one. So all of my ethene molecules break their double bond and they add together to make a long chain, which looks like this. And that keeps going and keeps going and keeps going for thousands and thousands and thousands of molecules, all joining together to form one polymer. When we draw the polymer, we usually draw it in brackets, like this. The reason for that is, as you can see at the moment here, we've got a bond going out to nowhere, and the same on the other side. That isn't really going out to nowhere. It's going out to yet another carbon atom. But we've got to stop drawing it somewhere. Okay, so that's why we stop. Okay, so eventually we've got to stop drawing carbons and hydrogens, otherwise we'd be drawing them all day. And so when we want to stop drawing them, we end it with a bond coming out like that. And that shows that we know that the molecule still continues to grow out in that direction. So there will actually be hundreds, if not thousands, of carbons in a polymer molecule, but we decide not to draw them just to make our lives easier. Okay. As I've said, we don't really want to draw thousands of molecules. To be honest, we don't even want to have to draw 8 molecules every single time we have to do one of these in an exam question. So there's a simpler way of drawing it. We could choose to draw part of the polymer molecule, like this. But a better way is to draw the shorthand formula. And the shorthand formula contains just 2 carbons. We draw on those carbons the atoms which are on them. So for example, in this one, I've only got hydrogens on my 2 carbons, and so I draw hydrogens on the 2 carbons there as well. We put it in brackets, and we write an N down here in the bottom right-hand corner. N stands for any number. And what it basically tells you is that the polymer contains a large number of the thing that is in the brackets. The thing that's in the brackets is called the repeating unit. So we've got our molecule, we've drawn 2 carbons, we've put it in brackets, and we've made sure that our bonds come out of the brackets on the other side. What that shows is that we know that the molecule is bigger than 2 carbons, and it just continues out in both directions. And we add the N to show that there's going to be a large number of the thing inside the brackets. Okay, so if I was asked to draw the displayed formula for the reaction of ethene to make polyethene, this is what I would draw. I would first of all draw the displayed formula of ethene. I would show that it's reacting together, and I would draw the product. Okay, basically all I've done, I've removed one of the bonds from the middle. Okay, I've broken my double bond. I've drawn my hydrogens in exactly the same place, just pointing up and down. I've made sure that I've drawn lines coming out of my carbons to show that I know that there is something bonded to those carbons, because the carbon needs to have 4 bonds. I've put square brackets around it, and I've added my N to show that there's going to be lots and lots of repeating things from inside the brackets. Okay, so in order to make polyethene, these are my conditions. I need a warm temperature and I need a catalyst. So this will not happen at room temperature. You need to heat it up and you need to add a catalyst. Okay, naming polymers is really, really easy. Ethene, as we have seen, makes polyethene. So Could we have a guess about what the monomer used to make polytetrafluoroethene is? Polyvinyl chloride and polystyrene. Have a guess, pause the video for a minute and see if you can guess what those monomers are going to be. Okay, it's very, very simple. All we have to do is remove the poly. Okay, so if we were looking at what the monomers are that make those polymers that are pictured, tetrafluoroethene makes polytetrafluoroethene, vinyl chloride makes polyvinyl chloride, and styrene makes polystyrene. Okay, so if we were given tetrafluoroethene, which is this molecule here, and we were asked to show what the polymer that's made of lots of tetrafluoroethene monomers looks like, then this is how we do it. Okay? First of all, we draw our two carbons, singly bonded, because remember my double bond is going to break. I draw my fluorine atoms on the same carbons. The only difference is instead of drawing them kind of diagonally out to the side like this, I've drawn them up and down a bit more so that I've got room for my brackets. Okay, so I've got my 4 fluorines in pretty much exactly the same position. I draw my 4th bond for each carbon coming out into the middle of nowhere. I put square brackets cutting through those bonds, and I draw my N. So that is the displayed formula for the polymer of tetrafluoroethene, called polytetrafluoroethene. So if I wanted to write this as an equation for the reaction, then I would start by drawing the monomer. I draw an arrow to show it's a reaction, and then I would draw my polymer. Like so. We can also go in the opposite direction. So we know that this is the polymer because it's got the N in brackets, and that only happens if it's the polymer. So this time I'm working backwards. I've been given the polymer and I need to work out what the monomer is going to look like. So this time, what do I need to do? I need to remove the N, remove the brackets, and I need to take away those bonds from the other side of the carbons. Again, these aren't going to change position very much. It's going to be the same atoms on the carbons, only the monomer is going to have a double bond between my carbons. So that's the monomer. And again, I can draw a similar equation for the reaction. These brackets you can choose to have in or not. It's up to you. But the ones on the other side of the reaction, these ones, must be there. Okay, the only way that this can become slightly more complicated is if your monomer has got more than 2 carbon atoms in it. So for example, propene, which has got 3 carbon atoms in it. And basically what we have to do with this is we've got to put it in the same format as the ones we've already seen. So we have to, in effect, get rid of that carbon and 3 hydrogens, because we only want these 2 carbons with the double bond in between. So instead of drawing it like it is on the left, we draw it like it is on the right. It's exactly the same molecule. All I've done is I've combined the CH3 there to look like the CH3 there. And I've just change the position slightly. And from there, it becomes easier to draw the polymer. Again, all I need to do, remove my double bond, draw everything out the same way that it was before the reaction, add my new bonds coming out of the other side of the carbons where they've joined to the next molecule, put my brackets and put N, just like it is here. Okay, so you're going to have a practice now. Okay, this alkene is a monomer. I want you to try and draw the displayed formula for the polymer that's produced from this monomer. So if you added many of these monomers together, what would the polymer look like? Pause the video here, have a go, see if you can do it. Don't just leave the video going and wait for me to give you the answer. In a minute, you're going to have some questions that you need to do on this. So now's the time to practice. Okay, so remember what we do. We remove the double bond. We draw everything else exactly the same way, just without the double bond. We put our square brackets with our bonds coming out, and we put our N. So it should look like this. Remember key points, same elements in the same places. There should be no double bond in your polymer. Make sure your lines are coming through your brackets to the outside, and make sure that you have got your N in the bottom right-hand corner. Okay, next one, we've got the monomer, and again, just look at the formula. This is how we write it. So it tells us that it's C, H, F, double bond, C, H, F. So that's my monomer. Pause the video, try to draw the polymer. Okay, so stages. We removed the double bond. We drew the square brackets. We put our lines coming out of either side of the square brackets. And we have our N. All right, last example. There's your monomer. Try to draw the polymer. Should be like this. By now you should have got the pattern. Okay, and then if we're given the polymer name, like polychloroethene, can you name for me the monomer that would be used to make this? Okay, so remember all we have to do is remove the poly from the beginning of the word, because polychloroethene literally means many chloroethenes joined together. So if we just took the monomer, one of them, then it would just be called chloroethene. Okay, ladies and gentlemen, you're now going to go to the Google Doc that I've provided, and you're going to answer the questions on addition polymers on the Google Doc. Okay, remember that you can come back to this video. You can watch parts of it again if you need to. Remember to also use your Caboodle textbook. Okay, follow the instructions on the Google document carefully. Post on Google Classroom if you've got any questions.